Good day everyone. So for today we discuss about carbohydrates. Before we proceed our discussion, I would like to present to you the members of our group. Philin Phineas, Julieta Pastrana, Jubijin Pano, Angeli Palma, Catherine Beronio, and yours truly, Labijin Pacheco. So now I will proceed our discussion. What is carbohydrates? So carbohydrates are sugar molecules along with protein and fats. Carbohydrates are one of the three main nutrients found in the food and drink. Carbohydrate is a large group of organic compounds that include sugar, starch, and cellulose containing hydrogen and oxygen in the same ratio as water, and used as structural materials and for energy storage within living tissues. For consisting of or containing a lot of sugar, starch, cellulose, or similar substances that can be broken down to release energy in the human body and make up one of the main nutritional food group. Carbohydrates are found in the wide array of both healthy and unhealthy foods like bread, milk, beans, popcorn, potatoes, cookies, spaghetti, soft drinks, corn, cherry pie, and etc. Why do we need carbohydrates? Carbohydrates are your body's main source of energy. They help fuel your brain, kidneys, heart muscles, and central nervous system. For instance, fiber is a carbohydrate that aids in digestion, helps you feel full, and keeps blood cholesterol levels in check. That's all. Thank you.
Structure of carbohydrates. All carbohydrates contain carbon, hydrogen, and oxygen, usually in a ratio of 1 to 2 to 1. As you can see in this linear model of a glucose molecule, which has 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Let's suppose to say that 6 here is 1 and 12 is 2. Now, we can say that the ratio of this linear model of glucose molecule is 1 to 2 to 1, or 6 to 12 to 6. There are 3 types of carbohydrates: monosaccharides, which are also called simple sugars, disaccharides, which are also called double sugars, and polysaccharides or complex sugars. Now, keep in mind that monosaccharides and disaccharides are also known as simple carbohydrates. Let us start by looking at monosaccharides. So, monosaccharides are smaller molecules, of which the most important being glucose. Glucose is a 6-carbon carbohydrate, and when it is dissolved in water, it will form a ring, as represented in this ring model. So this is how a 3-dimensional model of glucose looks like on the screen. I have shown you 3 different models here, but keep in mind that these models all represent the same molecule. 2 other important 6-carbon monosaccharides are fructose and galactose. Like glucose, both of these molecules have 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. But their structures are all slightly different. As you can see there, the position of carbon, hydrogen, and oxygen is different from one another. Not all monosaccharides are 6-carbon molecules, as ribose and deoxyribose have only 5 carbon atoms in their structures. Next is disaccharides, or double sugars. It is composed of 2 monosaccharide molecules bonded together through a dehydration synthesis reaction which results in the loss of water molecule. Some important disaccharide molecules include sucrose, maltose, and lactose. Sucrose or table sugar is formed when a glucose and fructose molecule bond together as you see here. As this bond takes place, a water molecule is removed. Maltose, which is found in sweet potatoes and many cereal, is the result of two glucose molecules bonded together, and again, water molecule is removed during the bonding. Lactose, which is mainly found in milk, is formed when a galactose and glucose molecule bonded together, and again, a water molecule is removed. The last one is polysaccharides. Polysaccharides are formed when many monosaccharide molecules bonded together. There are three polysaccharides that are important to the body. These are starch, glycogen, and cellulose. Starch consists of many glucose molecules bonded together, forming, and water molecules are also removed as these bonds are formed. Starchy foods include potatoes, rice, wheat, and corn. Glycogen. Glycogen is not a dietary carbohydrate, as it is a storage form of glucose found in muscles and liver. And lastly is cellulose. Cellulose is a component of plant food referred to as fiber. The human body cannot break the bonds of these molecules, so they are not digestible, but it has many benefits to overall health. And that be the basics on the structures of carbohydrates. Thank you.
Hi, this is Catherine Y. Beronio. Now, I will be going to discuss the classification of carbohydrates. The main classification of carbohydrate is done on the basis of hydrolysis. This classification is as follows. First, monosaccharides. These are the simplest form of carbohydrate that cannot be hydrolyzed any further. They have the general formula of CH2O. Some common examples are glucose, ribose, and etc. Hence, monosaccharides may be further classified depending on the number of carbon atoms. First, triosis, C3H6O3. These have 3 carbon atoms per molecule. For example, glyceraldehyde. Second, heterosis, C4H6O4. These monosaccharides have 4 carbon atoms per molecule. Example, erythrose. Similarly, we have pentoses, hexoses, and heptoses. Next classification is oligosaccharides. Carbohydrates that on hydrolysis yield 2 to 10 smaller units or monosaccharides are oligosaccharides. They are a large category and further divides into various subcategories. Next is we have disaccharides. Disaccharides, 2 monosaccharides combine to form a disaccharide. Examples of carbohydrates having 2 monomers include sucrose, lactose, maltose, and etc. Next is we have here trisaccharides. Carbohydrates that on hydrolysis gives 3 molecules of monosaccharides with their same or different. Example of this is raffinose. Next, we have here the tetrasaccharides. And as the name suggests, these carbohydrates on hydrolysis give 4 molecules of monosaccharides. Stevia is an example. Next, we have polysaccharides. This is the final category of carbohydrates. These give a large number of monosaccharides when they undergo hydrolysis. These carbohydrates are not sweet in taste and are also known as non-sugars. Some common examples are starch, glycogen, and cellulose. Starch is composed of 2 components, amylose and amylopectin. Amylose forms the linear chain and amylopectin is a march branch chain. Glycogen also is called an animal starch. It has a structure similar to starch, but has no more extensive branching. Cellulose is a structural carbohydrate and is the main structural component of the plant cell wall. It is a fibrous polysaccharide with high tensile strength. In contrast to starch and glycogen, cellulose forms a linear polymer.
These are the example of sources of carbohydrates with its respect number of calories can be acquired. For the first table, we have here the first source of carbohydrates with its equivalent calories gained. So as you can see in the table, the first column there represents the food group, which is the milk, with a higher percentage of simple carbohydrates but less in nutrient dense. The second column there represents the carbohydrates in grams. Then the third column there is the equivalent calories. Basically, a 1 cup of chocolate milk contains 26 carbohydrates in grams with its equivalent to 208 calories. Then for low fat with 2% milk contains 12 carbohydrates in grams with its equivalent to 121 calories. Then for the 1/2 cup of pudding with any flavor contains 30 carbohydrates in grams with its equivalent to 161 calories. Then for the 1 cup of skim milk, it contains 12 carbohydrates in grams with its equivalent to 86 calories. For 1 cup of yogurt with fruit flavored and low fat, it contains 42 carbohydrates in grams with its equivalent to 228 calories. Then for the 1 cup of yogurt which is frozen with low fat also contains 34 carbohydrates in grams with its equivalent to 220 calories. So we have here the second sources of carbohydrates with its equivalent calories gained. So in there we have beans. Beans have a higher percentage of complex carbohydrates, which means that it contains more nutrients dense. Based on the table, the 1/2 cup of black eyed peas contains 22 carbohydrates in grams with its equivalent of 134 calories. Then a 1 cup of garbanzo beans contains 45 carbohydrates with its equivalent of 269 calories. Then a 1 cup of navy beans contains 48 carbohydrates in grams with its equivalent of 259 calories. 1 cup of pinto beans contains 44 carbohydrates in grams with its equivalent of 235 calories. Then for the 1/2 cup of refried beans contains 26 carbohydrates in grams with its equivalent of 142 calories. Then for the 1 cup of white beans contains 45 carbohydrates in grams with its equivalent of 249 calories. For the third table, we have here the fruits, which is considered as the higher percentage of simple carbohydrates with less nutrient dense. So it is said that a 1 medium apple contains 21 carbohydrates in grams with its equivalent of 81 calories. Then for the 1 cup of apple juice contains 28 carbohydrates in grams with its equivalent to 111 calories. Then a 1 cup of apple juice contains 60 carbohydrates in grams with its equivalent to 232 calories. Then a 1 banana contains 27 carbohydrates in grams with its equivalent to 105 calories. Then a 1 cup of cantaloupe contains 14 carbohydrates in grams with its equivalent to 57 calories. Then for a 10 dates dried contains 61 carbohydrates in grams with its equivalent to 228 calories. Then for the 1 roll of fruit rolled apps contains 12 carbohydrates in grams with its equivalent to 50 calories. Then for the 1 cup of grapes contains 28 carbohydrates in grams with its equivalent to 114 calories. A 1 cup of grape juice contains 23 carbohydrates in grams with its equivalent to 96 calories. Then a 1 orange contains 16 carbohydrates in grams with its equivalent to 65 calories. Then for a 1 cup of orange juice contains 26 carbohydrates in grams, with its equivalent to 112 calories. A 1 pear contains 25 carbohydrates in grams, with its equivalent to 98 calories. Then a 1 cup of pineapple contains 19 carbohydrates in grams, with its equivalent to 77 calories. Then a 10 brownies dried contains of 53 carbohydrates in grams, with its equivalent to 201 calories. For a 1/2 cup of raisins contains 79 carbohydrates in grams, with its equivalent of 302 calories. Then a 1 cup of raspberries contains 14 carbohydrates in grams, with its equivalent to 61 calories.
For the continuation of carbohydrates with its equivalent calories gain, we have here vegetables with higher percent of complex carbohydrates, more nutrient dense. First is 1 medium of carrots, and it has 8 grams of carbohydrates, which is equivalent to 31 calories. Second is 1/2 cup of corn, and it has 21 grams of carbohydrates, which is equivalent to 86 calories. Next is 1/2 cup cooked of beans and lima. It has 20 grams of carbohydrates, which is equivalent to 108 calories. Next is 1/2 cup of green peas, and it has 12 grams of carbohydrates, which is equivalent to 63 calories. Next is a 1 large baked and plain potato. It has 50 grams of carbohydrates, and it is equivalent to 220 calories. Next is 1 large sweet potato. It has 28 grams of carbohydrates, which is equivalent to 118 calories. And lastly is 1/2 cup of 3-bean salad, and it has 20 grams of carbohydrates, which is equivalent to 90 calories. Now let's move on to grains with higher percent of complex carbohydrates, more nutrient dense. First is 1 bagel, and it has 31 grams of carbohydrates, which is equivalent to 165 calories. Next is biscuit, 1 biscuit, and it has 13 grams of carbohydrates, which is equivalent to 103 calories. Next is 2 sticks of breadsticks. It has 15 grams of carbohydrates and 77 calories. Next is 1 slice of wet bread. It has 12 grams of carbohydrates and has 61 calories. 1 slice of whole wheat bread. It has 11 grams of carbohydrates and has 55 calories. 1 cup of ready-to-eat cereal. It has 24 grams carbohydrates and has 110 calories. 1 oatmeal raisin cookie. It has 9 grams of carbohydrates and has 62 calories. Next is 1 square cornbread. It has 28 grams of carbohydrates and 178 calories. A 3/4 cup of cream of rice has 21 grams of carbohydrates and has 95 calories. A 3/4 cup of cream of wheat has 20 grams of carbohydrates and has 96 calories. English muffins has 25 grams of carbohydrates and has 130 calories. 1 fig bar has 10 grams of carbohydrates and has 50 calories. Next is 2 squares of graham crackers, and it has 11 grams of carbohydrates and has a 60 calories. 1 ounce of honey and oats granola bar has 19 grams of carbohydrates, which is equivalent to 125 calories. 1 hamburger bun. It has 21 grams of carbohydrates, which is equivalent to 119 calories. 1 hot dog bun is equivalent to 21 grams of carbohydrates and has 119 calories. 1 cup of spaghetti noodles has 34 grams of carbohydrates and it is equivalent to 159 calories. 1/2 cup of oatmeal has 12 grams of carbohydrates and has 66 calories. 1 packet of flavored oatmeal and Quaker Instant has 25 grams of carbohydrates, which is equivalent to 110 calories. 4-inch diameter pancake has 10 grams of carbohydrates and 41 calories. 1 slice of cheese pizza has 39 grams of carbohydrates and has 290 calories. 1 cup popped plain popcorn has 6 grams of carbohydrates and 26 calories. 1 ounce of pretzels has 21 grams of carbohydrates and has 106 calories. 1 cup of rice or white rice has 50 grams of carbohydrates and is equivalent to 223 calories. 1 cup of brown rice has 50 grams of carbohydrates and 232 calories. 5 crackers of saltines has 10 grams of carbohydrates and 60 calories. 1 flour or tortilla has 15 grams of carbohydrates and has 85 calories. 3 crackers of Triscuits has 10 grams of carbohydrates and 60 calories. And lastly is waffles. It has 17 grams of carbohydrates, which is equivalent to 130 calories. So these are some of the carbohydrates with its respective numbers of calories we can be acquired.
Good day everyone, I am Palma Angeli and I will tackle the recommended dietary allowances or RDAs. Recommended dietary allowances are the levels of intake of essential nutrients that, on the basis of scientific knowledge, are judged by the Food and Nutrition Board to be adequate to meet the nutrient needs of practically all healthy persons. The requirement of a particular nutrient is the minimum amount that needs to be consumed to prevent the symptoms of deficiency and to maintain a satisfactory level of the nutrient in the body. The first edition of the recommended dietary allowances was published in 1943 during the World War II, with the objective of providing standards to serve as a goal for good nutrition. It defined, in accordance with newer information, the recommended daily allowances for the various dietary essentials for people of different ages. That is according to NRC 1943. From the original application as a guide for advising on nutrition problems in connection with the national defense or RDS have come to serve other purposes: for planning and producing food supplies, for population subgroups, for interpreting food consumption records of individuals and population, for establishing standards for food assistance programs, for evaluating the adequacy of food supplies in meeting national nutritional needs, for designing nutrition education programs, for developing new products in industry, and for establishing guidelines for nutrition labeling of foods. Estimation of physiological requirements. Where possible, the subcommittee established a RDE by first estimating the average physiological requirement for an absorbed nutrient. It then adjusts this value by factors to compensate for incomplete utilization and to encompass the variation both in requirements among individuals and in the bioavailability of the nutrient among the food sources. The requirement for infants and children may be equated with the amount that will maintain a satisfactory rate of growth and development. And for an adult, it may be equated with an amount that will maintain body weight and prevent depletion of the nutrient from the body, as judged by balanced studies and maintenance of acceptable blood and tissue concentrations. establishment of dietary recommendations. It is necessary to take into account any factors that influences the absorption of food nutrients or the efficiency with which they are utilized. For some nutrients, a part of the requirement may be met by consumption of a substance that is subsequently converted within the body to the essential nutrient. For example, some carotenoids are precursors of vitamin A, since some or all of the vitamin A allowance can be met by dietary carotenoids. The efficiency with which these precursors are converted into vitamin A must be considered. The subcommittee that prepared the ninth edition of the RDA created the category Safe and Adequate Intakes for nutrients with databases insufficient for developing an RDA, but for which potentially toxic upper levels were known. In this category were three vitamins: vitamin K, biotin, and pantothenic acid. These trace elements, copper, chromium, fluoride, manganese, molybdenum, and selenium, and three electrolytes: sodium, potassium, and chloride. This is the daily nutritional guide pyramid for Filipino lactating women. Just take a look for a minute. And this is the daily nutritional guide pyramid for Filipino pregnant women. And this is the daily nutritional guide pyramid for Filipino children age 7 to 12 years old. While this is the daily nutritional guide pyramid for Filipino children age 1 to 6 years old. While this is the pyramid for Filipino children age 13 until 14 years old. While this is the daily nutritional guide pyramid for Filipino adults age 20 until 39 years old. We should eat a variety of foods every day to ensure that all nutrients are provided in proper amount and balance. How are these to be met? Because there are uncertainties in the knowledge base, it is not possible to set RDAs for all the known nutrients. However, the RDAs can serve as a guide such that a varied diet meeting RDAs will probably be adequate in all other nutrients. Therefore, the subcommittee recommends that diets should be composed of a variety of foods that are derived from diverse food groups rather than by supplementation or fortification, and that losses of nutrients during the processing and preparation of food should be taken into consideration in planning diets. This is the sources of RDAs, and thank you everyone. I hope you learned something from me. Goodbye.